welcome participants once again to the NPTEL MOOC module on exploring healthcare data. We are on the 6th week and explaining one of the topic which is sometimes required, okay, because of some reviewers may ask about cross checking or validating your models. That is on independence of irrelevant alternatives. Though it seems very unique, very different, but it is connecting to some of the specific models. It is usually discussed in the limited dependent variable model, especially after multinomial logit. So here it goes. Multinomial logit regression we have already discussed in the previous lectures. We are just trying to understand or validate the multinomial logistic regression with the help of this particular topic. I am just revisiting the multinomial logistic regression once again, just for your clarity, to introduce the independence of irrelevant alternatives. Multinomial logistic regression is in fact a simple extension of binary logistic regression that allows for more than two categories of the independent or outcome variables. So, as we already discussed in the previous lecture, that when we have more than two categories of the dependent or the outcome variable, not the independent one, I think I said as independent, you just correct it as dependent one. When the dependent or the outcome variable has more than two categories, we use multinomial logistic regression. Like binary logistic regression, multinomial logistic regression uses maximum likelihood estimation technique to estimate the probability of categorical membership. Okay. And now, a multinomial logistic regression is often considered an attractive analysis because it does not assume normality or linearity or homoscedasticity. So, these are important aspects which is very essential to discuss at this moment. That is why this kind of models, in case of when your data is not following the assumptions of normality or linearity, or it does not have homoscedasticity, or there are certain problems of heteroscedasticity, multinomial logistic regression could be used. Okay. This is also called, sometimes referred in the context of GLM, okay, though there are different contexts in GLM, but where the linear regression is not applied, the GLM can also be discussed, generalized linear models. So, multinomial logistic regression does have assumptions such as, that is called assumption of independence among the dependent variable choices. The dependent variable choices are the categories which we are essentially going to consider in the model to run the multinomial logistic regression. Those choices should be actually independent. If there are independence among the choices, I think if you are including or deleting certain categories or choice, your model is not going to be affected much. This assumption is popularly known as independence of irrelevant alternatives, or IIA. So, IIA whenever is discussed, so be confident about it and learn as per we just discussed. So, what does this mean? Independence of irrelevant alternatives. This means the assumption, which IIA just says, this states that characteristics of one particular choice alternative do not impact the relative probabilities of choosing other alternatives. In other words, IIA property states that the ratio of the probabilities of choosing any two alternatives is independent of the attributes of any other alternatives in the choice set. That means the ratio of the probability of choosing any two alternatives is also independent of the attributes of any other alternative in the choice set. This states simply that this assumption requires requires that the inclusion or exclusion of categories does not affect the relative risk associated with the regressors in the remaining categories. So, the relative risk, like those who are in the context of healthcare, this relative risk ratio are also taken. Largely this is called multinomial logistic regression. So, with the change in certain categories or choices, the risk is not going to be changed. Relative risk is not going to be changed much. One example is that if independence of relevant alternative is valid, how I choose between watching a movie or attending a football game is independent of whoever is giving a concert that day. So, like if another one we are adding as giving concert, when I am quite sure that between the choice between movie and attending football is in fact independent of another categories. Another one is if IA is valid, how I choose between public health insurance or community based health insurance scheme is independent of the features of private health insurance. Okay. If the choice has already been discussed between these two, if the third one is is introduced, that also not creating much difference in the model. That is why it is called independence of irrelevant alternatives. We discuss and describe the assumption in terms of the multinomial logistic regression with the help of this equation, probability of y conditioning upon the variables, okay, m alternative options, y having m alternative categories options with respect to or its ratio with respect to other alternatives, that is still m given its covariates, that is x or the control variables, is basically an exponential function, which we generally know that logistic multinomial logistic functions are expressed in exponential form. Okay. That is exponential form x within bracket beta m given x minus beta n given x, where the odds do not depend on other alternatives that are available. In the sense those alternatives are irrelevant. What this means is that adding or deleting alternatives does not affect the odds among the remaining alternatives. Test of IIA involve comparing the estimated coefficients from the full model to those from a restricted model that excludes at least one of the alternatives. Okay. The test which we involve comparing the estimated coefficients from the full model to those from a restricted model where some alternatives are actually excluded. Okay, so we will compare these two basically in this case. When this comparison by exclusion is not making difference between that of the full model, that means we can assure ourselves that the alternatives are not that important or are independent. If the test statistics is significant, that means our assumption is there is no difference. Now, the assumption of IA is rejected, okay, indicating that MLL is inappropriate. That means there is no difference. Here we are saying there are differences. Okay. So, like like if the test statistic is significant, the assumption of IA is rejected. If there are any alternative assumption is there that is rejected, this means the MLL which you have taken is in fact the assumption of independenceness is no longer there when we are rejecting. That means test is significant. So, there are in fact dependence, not independence of the alternatives. When there are dependence, then by if you are including certain choices, limited choices in the multinomial logistic regression, that may not be perfectly explaining the complete model. Okay. So, we are going to explain you about the test statistics in a practical session here. the condition of independence of irrelevant alternatives was first used by Arrow in 1951. A number of tests of independence of irrelevant alternatives exist. One test was devised by Hausman McFadden. This is where we are going to discuss as per the 1984 paper as a variation of the Hausman 1978 test. Okay. So, Hausman McFadden test, this is relied on the insight that under IIA the parameters of the choice among the subset of alternatives may be estimated with a multinomial logic model on just this subset or on the full set, though the former is less efficient than the latter. Because since we have restricted our model, first one is the subset, second one is the full set. Since we have restricted our model, so that is not expected to be more efficient than that of the full model. If II is not true, that means if there is no independence of alternatives are not independent, that means we have to reject. Okay, the parameter estimates of the full sets are inconsistent, whereas those of the subsets are consistent provided that the subset is properly selected. This test is implemented simply by two logit estimations and an evaluation of the difference in the parameter estimates. The difference of the parameter of these two models are most important. Other tests include one designed by Small and CIO in 1985 paper, which builds on McFadden, Train and Tai paper. Another test proposed by Hausman McFadden 1994 based on the estimation of the nested logic model, basically nested with the alternatives included or not. Then test based on regression based statistics by McFadden as well in 1987 and Small 1994. A non-parametric test model was also suggested by Jane and a test by Wheezy 1999. Hausman test compares the maximum likelihood estimator of beta coefficient based on all data with maximum likelihood estimations of beta that are based on data in which one alternative beta is dropped. Okay, one alternative beta is dropped, while cases in which beta was actually selected are fully dropped. Under IIA, beta restricted and the beta overall should be approximately equal. Okay. If they are approximately equal, that means there is no difference, while equal, while IIA is violated if the two estimates of beta are different. If these two estimates of beta are different, then IIA is in fact violated. So, in the test that should not be significant. If it is significant, that means there are differences. Formally, Hausman has shown that the beta statistic is like this: H is equal to BR minus BF, inverse of this VR and VF, and its difference is multiplied. This is approximately as the chi-square distributed under the null hypothesis as independence of alternative hypothesis, where B and V denote the estimate and the approximate variance matrix based on full F and the restricted R stands for the restricted model and F stands for the full model. So, this difference we are just getting the difference between these two, okay, in each of the cases. One is in the case is B for the estimate and V for the variance. So, each indicator is included in this equation. So, in the session we are just going to clarify through our approach. Okay. So, here are the details on your screen. This is what we have opened a data window on the screen. Now, we are going to open the data set which we have sorted out, a sample data set we are also going to share with you, and this is based on insurance which you have already discussed. There are two insurance if access is there. The third choice, if you are including, if it is not making much difference, that means there is independence of irrelevant alternatives. So, now we are taking going through by our do file. We will also suggest what are the commands. Like first one is we will run the multinomial logit using two variables. Ensure is in fact our dependent variable, okay, and this is our first model. All right, mlogit we have derived, then we will go for its estimates, and then we will store all its estimates. Okay, this is the second command we usually give. Third one is we will compare this on ensure to ensure, okay, in the mlogit command. This is the third command we have to give. So now we have got these differences. The last one we wanted to check with their estimates and their partial values as well. So then we will perform, after having these differences in the mlogit, we will finally perform the Hausmann test. Okay. So to perform Hausmann test of irrelevant alternatives, so this is what our chi-square value which we have already said. This is what the equation displayed on your screen, b minus capital B, and its variance. B stands for the R, that is restricted model, small b, capital B for the full model, and its coefficient. Based on that, the chi-square value is on your screen, and that is in this case is as discussed is not significant. Okay, the coefficient is 0.08 and not significant. So if it is not significant, which already we have said, if the chi-square model based on these suggestions by Hausmann, if this comes out to be significant, that means that there are difference between the restricted model and that of the full model. Okay, and in the restricted model we have dropped one category, and in the full model all entire model, options are taken. So the difference, if since it is not significant, that means there is no difference between these two models even with certain restrictions. So that does indicate that if you are adding more variables in the dependent variable category, in that case this is not going to differentiate our result. So that way we say independence of irrelevant alternative holds correctly. So this is what we have given in our model, in our slides as well. Hausmann test, this is what is the coefficients we just derived, and the difference we have also derived, small b minus capital B, B stands for the full model, capital B stands for the full model. So each of the difference is actually derived here. Okay, and the square term as per the suggestions given is also calculated, and then a test is taken. For the assumption here is that there is no difference in coefficient, and that coefficients are not systematic. Okay, so non-systematic assumptions were taken. The null hypothesis is in fact is a difference in coefficient, that is non-systematic. So systematic used to be non-random, non-systematic is in fact random. So the difference whichever is derived between these two is expected to be having a distribution, okay, that is maybe normally distributed. Since in our model we have said that the difference is itself insignificant, so there is no distribution of those differences. Okay, so the model is in fact following IIA correctly. It is evident from our result that the null hypothesis is being rejected, which shows that the difference in coefficient is systematic and IIA assumption is not violated. Okay. So what is this then? Like what are the cautions we need to take regarding IIA test? Some of the caution: the third edition of Long and Fries, as per the pages and their reference we have cited, explains that the assumption explains about this assumption further, and also explains the ways of testing it. Long and Freeze also test for IIA in their programs, but do not encourage their use. They strongly said that do not use this, do not encourage to use it. They note that these tests often provide conflicting results because some tests reject the null while others do not, and that various simulation studies have shown that these tests are not useful for assessing violations of the IA assumptions. So, this has to be noted carefully that you may avoid using these techniques. They further argue that the multinomial logit model works best when the alternatives are dissimilar and not just substitutes for one another. Okay, that is, if your choices were taken your car to work, or like where like take your car to work, take a blue bus, take a red bus, the two bus alternatives would be very similar, and the IA assumption would likely be violated whether the test showed it or not. So, these are details. Another clarification, you can always try to convince the reviewers. If you are receiving this type of comment from the reviewers, you just always try to clarify about the IIA as to convince the reviewers that or editors that these tests do not provide useful information. Okay. To prove your point, you can cite Fry and Harris papers, Cheng and Long, J. Scott Long and Jeremy Freeze book entitled Regression Models for Categorical Dependent Variables Using Stata Addition. So, in the conclusion, though we have explained in one lecture, after reading thoroughly and we thought that we should give you one direction for your clarification. Some reviewer asked for some clarification about your independence of irrelevant alternatives, but it is suggested that if you run different models, it may not be necessarily going to be insignificant every time. Okay, and this is not a very robust way of saying the fact that alternatives is not going to differentiate your result. So, it is suggested that you please avoid this kind of result, but if you just want to give you the minimum information to the reviewer, then you can calculate by using the formula or the package, the do file we have shared. That will be very helpful. And this is though a very tiny issue, but sometimes useful in research. With this, I think we should close here, and we look forward to your participation in the next class for a better lecture. Okay, thank you.